So in this video, we will understand this CAD and CART to transform the financial decision making processes. So let's start with this chi-square automatic interaction detection, or the CAD. So basically this CAD is a type of machine learning algorithm widely implemented in finance to uncover this hidden relations between the large set of categorical data. Now this CAD facilitates the identification of significant correlation between different categories by dividing them hierarchically into smaller mutually exclusive groups based on the statistical text. So in doing so, CAD can elucidate causal links between the various financial parameters, revealing critical insights that support evidence-based decision making. So consider an insurance company wishing to comprehend the primary determinants contributing to a motorcycle or motor vehicle accident. So using this CAD, the insurer could input an extensive database comprising demographic profiles, driving history, accident records, weather conditions, road infrastructure, and other relevant factors impacting driver safety. So after running this algorithm model, CAD would classify drivers based upon their propensity to collide, highlighting the most prominent risk factors such as age group, driving license, geographical location, vehicle make, model, and weather patterns conducive to mishaps. And with these discoveries, the insurer may adjust premium prices, restructure the policy coverage, or launch specific awareness campaign tailored towards mitigating hazardous situation. So altogether, this CAD strengthens firms' analytical capabilities, enhancing competency in underwriting decisions, claim handling procedures, and risk assessment endeavors. So to understand this better, let's understand it using a Python code. So here we are first importing the necessary libraries, that is sklearn, numpy, and pandas, and then we will load our financial data set from CSV file known as financial data.csv. And next we prepare the data for the model. So first we convert the target columns which contain yes or no values into an integer array where yes is represented by 1 and everything else as 0. Secondly, we drop the target column from the main data frame X using pandas and convert it into a numpy array. Now we define the maximum number of levels in our decision tree as 5. This means that our decision tree will have to take 5 layers of branching until it reaches a leaf node representing the predicted output. So afterward, we initialize this CAD model using this decision tree provided by the scikit-learn. So here we specify that we want splitter the best to choose the best splitting criteria automatically, and we also choose the criteria chi2, meaning we want the chi-square automatic interaction detection method to detect any meaningful relation between our independent variables. And then we train the model using fit function using scikit-learn, passing in our feature matrix X and target vector Y. And finally, we print this overall accuracy of our trained model and generate a visualization of this constructed decision tree using plot tree. And lastly, we display the generated results using plt.show. So overall, this code implements the chi-square automatic interaction detection test, which is used to construct a decision tree for predictive modeling and classification purposes in finance. Now next comes this classification and regression trees. Now this classification and regression trees is another popular machine learning technique which is used in finance, and it works similarly to this CAD, but it has two different variations: classification trees and regression trees. So both models helps in identifying the most influential factor relating to that particular phenomena by splitting data set into increasingly refined subsets using binary splits until that desired outcome is achieved. So while classification tree will forecast discrete results, regression trees anticipate continuous values. So let us consider how a stockbroker might utilize this card to determine the likelihood of successful IPO investment. So by feeding this historical data encompassing this company details, industry sectors, management expertise, funding sources, market conditions, regulatory frameworks, and similar stats, the brokerage firm could build either classification or regression tree depending on its objective. So if the firm aims to estimate post-IPO share price trajectory, it would use a regression tree because it predicts this numerical figures. On the contrary, if the intention is to foresee whether that new enterprise will meet its public offering goal or fail miserably, then organization would employ a classification tree because of its capability to predict dichotomous outcomes. So ultimately, both techniques offer valuable insights and for the traders and investors to formulate these winning strategies. So to understand this card better, let's understand it using a Python code. So first, in this code, we are importing the necessary libraries like NumPy, Pandas, Scikit-learn, Train modules, and the metrics modules to implement this card technique for both regression and classification problems. Now we will read a CSV file using this pd.readCSV function provided by Pandas library, and we save the content of this file in a data frame object called df. Afterward, we separate the input variable, also known as features, from the target variable and store them separately in a new data frame called x and y separately. And then we initialize a decision tree regressor model, passing a value of 0 for the random state parameters so that the model starts from the same initial point every time it runs. And the next step is to fit the newly initialized model to the training data stored in x and y arrays. So once fitting is completed, we calculate the mean absolute error between the predicted prices written by fitting model when applied to this original input data set x and the actual closing prices saved in the y firm. And we also calculate this coefficient of determination, or the R square, which determines how well the model fits this training data. And finally, we print the results. Then next, this is the code for the classification. So here we are loading a CSV file called creditscoring.csv into a data frame named df using this pd.readCSV function from the pandas library. Then some of the columns contain categorical data such as gender, loan, purpose. So we convert them into the numerical values that can be used directly in the machine learning algorithm. And this process is called one-hot encoding, where each category becomes a separate feature in the transform matrix. And to do this, we loop through all the columns containing categories, create dummy variables for each category using pd.getDummies function, and concatenate the resulting matrix with the original ones, drop duplicate row values. And once we finish converting categorical variables into binary columns, we split the dataset into two parts: independent variable, which is stored in a new data frame called x, and dependent variable stored in series called y. And after separating this independent and dependent variable, we initialize a decision tree classifier algorithm and set its random seed at 0 to ensure reproducibility. Then we train this model using fit method, and we use the score method to measure how accurately the learned decision tree makes predictions based on this training data. And the results represented by accuracy variable indicates the presence of correct decisions made by the model, and we print the computed accuracy using a print statement. Thank you.